Welcome to this afternoon's post-shutdown news conference. Our participants from your left are Leonard Nicholson, Space Shuttle Program Manager, Steve Nagel, Commander of the STS-55 Flight Crew, Professor Heinz Stuver, Managing Director, Space Utilization, German Space Agency, and D2 Program Manager, Robert B. Seek, KSE Launch Director, and Alex McCool, Shuttle Projects Manager, Marshall Space Flight Center. And we'll start off with Mr. Nicholson.
Good morning. As all of you know, we had a shutdown on the pad this morning. What we know so far is that main engine 3 shut down, and we believe the cause to be most likely in a check valve. We have a purge system on that engine prior to startup. When the engine starts up, there's a check valve between the purge system and the high pressure gas. We believe that the check valve failed to close, allowing some of the high pressure gas to get into the purge system of the circuit. We have a pressure transducer in that circuit that senses whether or not the pressure in the purge line is declining as it should. In this case, it did not decline as it should. Instead, we saw a pressure increase, and the red line is there to detect that, and in fact did so and shut the engine down. Any further details, we would have to, of course, wait until we have gotten into the hardware and seen precisely what the condition of the hardware is. We do not as yet have a schedule for what work would have to be done, and so we will have to give that some more time before we can say very much about our future planning. And with that, I would turn it over to Steve.
Commander Nagel?
Well, I'll say it's nice to be here. I wish I was somewhere else right now. But naturally, if I'm honest with you, it's a disappointment that we're not flying. But on the other hand, I think it's a real testimony, first of all, to the hardware, that it works the way that it's supposed to. If a parameter's out of limits, that the computers automatically safe the engines and shut them down. And secondly, I'd like to take this opportunity to pay tribute to the launch team, who did a superb professional job. You know, immediately after the shutdown, the crew goes to a page in their checklist for scrub turnaround, and there's some actions in there for which we wait the commands from the launch team, which we very quickly got. They kept us appraised of exactly what the status was, and we marched through that whole set of procedures and a lot more very quickly and thoroughly. And I'm very proud of the whole team and the job they did. So we'll be back to fly again very soon. Thank you.
Professor Stuver?
Well, obviously, I would have preferred also not to sit here. Obviously, we're also disappointed that the mission didn't go off. But on the other hand, I can echo what Steve has said. Our reaction was safety first, and the fact that the systems have worked the way they did, detected an anomaly and then shut down, is something which I think one must praise in a context like this. We will work with our NASA colleagues over the next few days and weeks to find out what the cause was and particularly what the remedy will be. I hope that we can get back in a launch condition soon, but I hope even more that when we're ready for launch and the darn thing lifts off, then this is going to be a very, very safe mission.
Well, a little adding more to Leonard's description there of the shutdown, that it appears that we had a check valve failure in the purge system for engine number 3. We're still going through the data associated with that, and we'll have hands-on access to the hardware when we complete our safing sometime on Wednesday, and we'll of course have more results from the data review. In the meantime, the effort out at the launch pad is to continue the safing of the hardware and gain the access so we can go in the aft compartment and start looking at the engines and find the hardware that did not work, although we have a pretty good idea what that hardware is. And what has been mentioned here is what did work and worked very well was the safety system, which ensures that the critical components performance is nominal before we commit to flight. And that worked in an excellent fashion. The onboard computers sensed the overpressure in this line, shut down the engines in a safe, orderly fashion, and the launch team executed their procedures, the safing procedures, which is a combination of hardware, software, and manual calls in a flawless fashion. As a result, the crew is safe, and the vehicle's on the pad, and it's safe also. And when we find the hardware, we'll fix it, and we'll get on with flying that machine. Obviously, we're all disappointed that we didn't fly, but our primary goal that the launch team focuses on is taking care of the customers, and the crew is our customer as well as the payload is our customer. They're both safe and sound today, and we'll find and fix the problem and get on with flying D2. It's just going to be down the road a little bit. Alex?
We have many purges on the engine. The purges there to protect the safety of the engine. What we're talking about here is a purge that should have closed or shut down just before ignition. And unfortunately, one of the check valves hung open, we believe, based on the data we've seen. And we got, just like Bob said, that the controller picked up on this. One of the red lines was exceeded. It should go to really 14 psi or to ambient, and we were up around 50 psi. Therefore, it told itself, I've got a problem, shut down. This is one of our launch commit criteria. It does it automatic. So it is a safety device that we have in there. We have purges there in the beginning to make sure in the engine system to keep all the moisture out. And then we turn these purges on after we shut an engine down. And the reason for that is to sweep all the combustion products out of the combustion system. Now we have 5 check valves in the engine. The main dome and the main combustion chamber, where the main propellants and all that are ignited, and then the 2 pre-burners. 1 check valve in the main combustion chamber, and 2 and 2 on the 2 pre-burner. A fuel pre-burner drives the fuel system, an oxidizer on the oxidizer system. And we believe it's probably on the oxidizer system that the check valve failed. Like Bob says, once we get out, we'll do the troubleshooting and failure analysis. Our people are already moving with our contractor to set up a failure analysis team, because we want to look and see what is the problem before we go to some different engines to understand, is it generic. We don't believe it's generic. It could be something, but we want to look at it, and we will get those valves out as soon as possible and analyze them. Take them back to the factory possibly with a team and see what the problems are and try to understand it better. So bottom line is, like was mentioned here, we did get a shutdown because of 1 valve hanging open, allowing the pressure not to be to ambient, but going to something like 50 psi, therefore giving us a shutdown. And it told all the other engines to shut down. We wouldn't lift it off that way. So that's it.
Any questions this time? Please wait for the mic. Give your name and affiliation, please. Bill, hold your hand up, please. Bill Harvey.
Yeah, Phil Harwood, CBS. For 2 questions. A quick one for Bob. You once said after return to flight that an RSLS abort was a minimum 2.5 to 3 week turnaround just to service the engines. Is that still the figure I should use for this mission? And the second question for Lynn, I realize you haven't settled on a schedule yet, but could you at least assess the options and what the issues are that would play in terms of keeping Columbia next in line or pushing it back behind Discovery and going ahead and launching Discovery off Pad B? Could you address those issues?
Well, answer to the first question is yes. It's 2 to 3 weeks. In this case, though, there's additional work to do with these check valves, so that would be additive. But that's the ballpark.
In answer to the second part, we of course, as we mentioned before, would look at the specific dates that come out of the results of this failure and recommend a strategy. We are retaining the capability to launch Discovery as soon as it would be ready, and the estimate, Bob, I believe, is somewhere around the 6th or 7th. And so we're going to be working that in parallel with understanding this problem. Once we have a firm schedule for the work necessary to get to Columbia, we will then accumulate that data and talk to our customer, both for Atlas and for the D2, and reach a determination. Our target for doing that is later this week. So we hope to resolve the question of what is our launch plan going to be by later this week. And in the meantime, we're going to press forward on both paths as aggressively as we can.
Todd.
Todd Halverson, Florida Today for Commander Nagel. I wonder if you could put us in your seat. You were strapped to your back and you're 6.6 seconds before launch. I'm wondering if you can tell me exactly what was going through your mind at that time and what you were feeling from that point on.
I knew we were going up to that point because the weather was great, everything had gone so smooth, and I'd convinced myself in my own mind we were going to fly. And when the main engines start, you hear them, feel them, and see the PC meters, the chamber pressure meters start up. And I was just looking over at that gauge over on Tom's side at that time, and it all happened in a second or two. As soon as they started up, I saw the red light on the right main engine, followed real quickly by the left red light and then the center, and they were all shut down just in less time than it took me to tell you that. So it was just all over by that time, and then I knew we were into an abort and turnaround. So we opened our checklist to that page and awaited further instruction.
And I had a quick one for Mr. McCool. Is this a valve that would have been tested during the frequency response test during the regular flow, and did that valve pass that particular
Yes,
test?
it did. It was tested in the fall of '92. It was tested, and we do that on all our components, testing before. They've been checked out, and was checked out okay.
One more follow-up, Todd.
Okay, I was speaking in particular of the FRT that you performed prior to launch. Maybe this is for Bob, whether that particular valve would have passed that FRT test.
I don't remember, though.
It gets a leak check, as it were, in that process, but I'm not sure about a cycle.
Ross?
Ross Cabot with Channel 9. Todd got my main question, but for Commander Nagel, I believe 4 people on the crew flying for the first time. What was their reaction? Did you have to calm them down, or did they have any reaction?
No, I think the predominant reaction was just disappointment, you know, and I assured everybody, especially those on the middeck, can't really see what's going on, so I assured them that everything's okay, you know, just sit tight, and we're probably going to have a normal, orderly egress at some time later, which we did.
Sue?
Either way you shove Columbia and Discovery, Len, won't you be down to 7 flights this year? And is any consideration then of moving Hubble into 94?
Sue, we don't think we're there yet. We think that we have some room in the schedule yet to account for such a problem, and particularly our situation for the year would be easier, of course, if we launched Discovery next. But it does not drive us totally out of the 8 flights, even if we cannot. So, but you're right, it's going to be getting tight, but we're not there yet.
Go ahead.
And my follow-on question, which is a little different, is in a worst-case scenario, could it have exploded in flight? Was the crew ever in danger sitting there when you did shutdown?
No,
No.
we have safe procedures for shutdown in the engine, and we would not have lifted off with this valve in the improper position. That's what this particular criteria and hardware lash-up precludes. And once the valves are closed, then everything is fine, and we would have had a normal flight.
Mark Crow, want to hold your hand up there, please?
Mark Crow, the Houston Chronicle. I have a question and a follow-up. First, Mr. McCool, could you go over the engine start sequence and just tell us which one started by number and then which one didn't, and then what happened?
Okay, the times that I have here, and I think, Bob, you said these times are what now, from start command?
From start, engine 3 comes up first. It goes 3, 2, 1.
3, 2, 1.
And there is a delay in there as part of the abort sequencer. When a major component fail is detected, the onboard computer logic will ensure that you don't shut all 3 engines down simultaneously. So there was a delay in the last engine to come up before it finally was shut down, so that you don't get this simultaneous reaction. So it's a 3, 2, 1 sequence, starts about 6.8 seconds before liftoff, and the last engine was in the safing mode at about launch minus 3 seconds.
So three did start and then shut down, and the other 2 followed?
Right.
That's right.
My follow-up question was for Steve Nagel. Could you just sort of give us an idea of how your crewmates are after the experience? and what you folks will do now to maintain your training profile and where?
Oh, they're all doing fine. Of course, we wanted to launch today, so they're disappointed. But it depends on how long we slip for. But I would guess if we slip for a month or so, somewhere in that ballpark, we'll have some additional payload training. Perhaps, I don't know, another joint integrated simulation with Germany. I'm not sure about any of this. I'm just speculating. We'll do some more on-orbit training. We'll do some more ascent and entry training, perhaps some of that integrated with mission control, and then we'll be back here to fly again.
You're leaving today?
Yes, we're leaving today.
Irene?
Irene Brown with UPI. For Bob, just a quick clarification. Did main engine 3 start and then was shut down automatically, or
Yes.
did the valve failure? Okay.
That's the onboard hardware and software detected the failure and did the initial safety. And then the rest is a combination of hardware, software, and procedures executed by the launch team and the crew.
Why was there such a difference in how the engines looked then? If main engine 3 was up and running, why was there such a dramatic difference?
Well, I don't
between
believe it was running. No, I was watching 3, and you don't see the mock diamonds. So we didn't ignite the pre-burner, okay? It was not running. It was not up and running, position 3.
In the start sequence.
In the start sequence.
So it's building up pressure.
It's building up, but I don't believe we got ignition in the pre-burner on the oxidized side.
Chris, we have a cluster of questions there. Holman, want to hold your hand up, please? Lady right behind you.
Oh, Omar Machuca, CRC and Cosmo 1270. I understand Commander Nagel shut off the switch, or was the computer that was shut off the system?
Computer. Yeah. The computer.
Jay Barbary.
This is for Bob and for Lynn. Bob, what's your best guess in time of a delay on Columbia? Can we assume, Lynn, now would it be safe to assume that you'll fly with Discovery before you fly Columbia?
You want to answer the first one, Bob?
Well, it's a minimum of 3 weeks of work plus a launch count if you just focus on STS-55 for what it would take to get that flying again. And the rest are the options that Leonard already went over. But
And I'll just, we talked yesterday about the various scenarios, and we sure enough plopped down right in the middle of the tough one. So we're going to have to look at the schedules and sit down with the Germans and the Atlas folks and make a decision. Jay, we have not reached that decision yet, but like I said, we plan to do that this week. We're right in the borderline case that you guys predicted we might be in. Sure enough, here we are.
Yes, sir.
Murphy has struck.
Julia Hansen, Voice of Germany, Radio Deutsche Welle. What abort mode would apply if you would fly out with 2 main engines running and the both solids running?
Well, I'll answer that. It would not have launched that way, first of all. If you lose one main engine very early in the ascent like that, you have to return to the launch site. So it would have been a return to launch site abort.
Chrissy.
Beth Dickey with Reuters. For Steve Nagel, could you please just address if there was any sort of, I'm over here, Steve, to your left.
Where are you?
If there was any sort of a tinge of fear at all on board when all of this took place, and Bob, could you address the tense seconds there in the firing room and what was going through your head when the engines shut down?
No, I wouldn't call it fear. I mean, there's a couple of moments wondering what happened because all you see on board are red lights and the engine shut down. So you know that the computers saved the engines, but you don't know why or exactly what went wrong with them. So, those reassuring words, not specifically what went wrong, but reassuring words that everything was okay came very quickly to us. So there weren't many moments of worry. It's mostly just disappointment. But I would say, rapidly just picking up from there and getting into the procedures to safe the airplane.
And from the team's perspective on the ground, the initial reaction is to go into a set of procedures which, as you would expect, we have practiced many times before. And that's exactly what the team does. We practice engine shut-offs and having engine leaks and even fires, just to keep the team sharp on those procedures that we hope we never have to execute, but occasionally have been called on to do before. And that set of procedures takes between 5 and 10 minutes before you're finally through what I would call the hectic phase, and then things slow down a little bit, and you can address when you're going to drain the tank and go on with the rest of the safing. This is our my third pad abort. It's the program's third pad abort, and we'll go through all of the data. We'll play back all of the voice tapes and go look at all the procedures and see if we graded out as well in hindsight that it looked like we did in real time. But I think as pad aborts go, this is probably the best one that we've executed. And again, it's a combination of hardware, software, and people executing procedures that pulls off these safing sequences. We practice them, and we'll continue to do that.
Greg?
This addresses Beth's to some degree. I remember distinctly after this happened with Discovery, Tom Utzman describing himself as puckered up afterwards. Not suggesting a break in professional reserve at all, but do any of you all have any similar colorful observations at that time?
Well, there's the tenseness is a better word for it, because your initial reaction is to make sure that there's no leaks or that there's nothing that's broken that's causing a hazardous condition, particularly in the aft fuselage. So you're very key to the call-outs from the team on verifications of leak detectors, fire detectors, valve position indicators, and you really don't have time to think about anything else. And then when that is all over, 5 to 10 minutes later, then you can think about the all shucks and everything else that went with it.
Ryan Cabell from CNN. Have any of the science experiments been lost or jeopardized as a result of this delay?
Well, I don't think so, but I am pretty confident that we will decide to go into the Space Lab now, the so-called MVAC operation, to do a little bit of maintenance, to replace some of the samples, and to make sure that everything stays sharp and fresh.
Dan?
Yes, Dan Billow, WESH-TV. Alex or Bob, just to clean up the question on the engine number 3 starting. Engine number 3 never got started. Looked like engine number 1, I believe it was, did. Why didn't engine 3 start? Because it was cut off, or because it couldn't start because the valve was open?
Well, we exceeded the red line, and therefore it had what we call a failure identification controller. It shut that engine down and told the other two to shut down. So it never got up to, let's say, the pre-burner igniting and getting the power that it should need. This was on position 3 that we talked about. So it got a red line cutoff and told the other two engines.
One more.
And
Go ahead.
just the other two engines did ignite.
Oh, yeah.
Okay,
That's
and
right.
then my real question was, the history of the pedigree on this engine or the equipment with it. Has any of that equipment or of that SSME been involved in any other problems in the past? For example, any of the
Nope.
other two aborts, anything like
No,
that?
no problems like that, and in fact, the history on that check valve was better, those check valves better than the other two engines. So and we have that data already. Now, we're going back, that's not to say that we may have not had some other problems, but not on these specifically, because they've been checked and tested and everything. So we're going back and looking to see what our history has been in the past on check valves. But these were all good.
We'll take one more question here before we go to the other NASA centers. Shreesh?
Shreesh Date with the Orlando Sentinel. A couple of questions. First, for Len, if it turns out that that for program reasons you choose to launch Discovery next, then will you have to wait until you finish the failure analysis on these engines before you even get into account with Discovery?
Well, we certainly want to understand what happened and assure ourselves that it doesn't have any application across the fleet. We don't expect that, but as you remember, I mentioned the first order priority is to get those check valves out of this engine, and get them off to failure analysis. We fully expect that that would support, with room to spare, any next flight. So we think we'll understand that before we get to our next flight.
And for either Bob or Alex, is there a chance that it was the transducer problem and not the check valve, or is there any way of knowing that until you get it
I
out?
believe it was a check valve. Most of our people believe it's that. Of course, we'll look at transducers and so forth. But adding to what Lynn says, tomorrow morning we'll know. We'll have our plan laid out with our contractor to know what we're going to do on the failure analysis for those check valves. Our people on the phone right now at this moment discussing this. We plan to have a meeting first thing in the morning to know. They can't get access anyway to tomorrow afternoon probably. But once it gets out, we know what we're going to do, and like Lenny says, there's no question, we won't be the pacing item for the next decision, what we'll do. We'll have an answer for that, hopefully.
Do we have some questions at the Johnson Space Center?
Go ahead, Dan. Hi, this is Dan Feldstein of the Houston Post. For Mr. Seek, could you describe for us what manual actions were taken after the abort, both in the orbiter and at the control?
Well, let me indicate what goes on the ground and have Steve talk about the crew participation. The ground activities after our software executes, which takes about 2 to 3 minutes, and that's a number of commands and verifications to our water system, our deluge system, and our main propulsion system. Then we turn it over to some manual actions that we do with the liquid hydrogen, the liquid oxygen system, and our purges. And before we make those actions, we get verifications from the people responsible for those systems that all of their information is consistent with changing the configuration that we went into terminal count. And that's, again, about a 5 to 10 minute activity. And at that point in time, we declare ourselves safe and we're ready for the next step. In the meantime, we're getting the closeout crew, ready to go back out to the launch pad to assist in the egress of the flight crew. And Steve, you can address your...
The scrub procedures in our checklist is just 1 page long, but none of it's done on our own. It's all done command response from the crew on the ground. It involves such things as safing the backup flight computer, turning off the APUs, safing the OMS engines, and then after that, just a whole series of switches and circuit breakers, command and response from the ground to safe the airplane.
Another question, JSC?
You have a follow-up? Yes, and my second question was for the German space representative. After the series of delays here, how do you think this is going to play at home? What do you think the response is going to be from German space workers and from German citizens?
Well, I think we're all disappointed that we didn't go off. This, I think, is a universal feeling here as well as back in Germany. I think more importantly is to understand why it didn't go off, and I think this was discussed here very clearly, and we'll explain that to everybody back home as well. I think everybody will stand behind accepting the fact that such missions are complex, but the only thing that really counts in the end are 2 things. Firstly, they're safe, and when they're flown, that the results will be good. And I'm hoping for both.
Does that wrap JSC?
This is Stephen Govain with KTRK-TV for Mr. Nicholson. It's been a long time since there was a mission that was quite this snake bit, if you'll permit that phrase. How do you think this is going to play with the detractors, the program detractors in Washington at this particular time when so much is being made of reduction in costs with space station and so on? Do you think that they will try to make any hay out of this?
Well, Steve, I don't know, but I think you need to look at the record that the team has had in recent years, which is absolutely outstanding in terms of making our flights. And we're going to have these kind of problems occasionally in a system as complex as this one, and we will recover from this in a very professional and safe manner and proceed on with meeting our commitments for this year. So I would say to those people that I think we've demonstrated that we know how to operate this machine in a safe way. This is not an operational system, and we're going to have these kind of problems, but we think we can overcome them and get back on track and plan to do that.
Understand we have a question or two at Marshall.
Martin Berkey at the Huntsville Times. First of all, what happens if the check valve does not close, and what would the 50 psi figure indicate about the position of the valve?
I didn't get the first part, I think, Martin. You say what would happen if we got the engine ignited? Was that your question?
Check valve did not close when you ignited the engine, and what would the 50 psi number indicate about the position of the valve?
Well, it doesn't read valve position. If you see, you should go to ambient. You know, it's supposed to bleed down. We're not supposed to have any pressure there, and we saw the pressure on the transducers. But and therefore we got a red line cut because it was something like 50 psi. I'm not sure I'm following you, Martin, for the second part.
Second, I'd like to know how many previous shutdowns have been caused by the check valves, and what did the problem turn out to be on those missions?
We haven't had any down here. I was able to research that. We've never had a problem at launch like this, never in the history of the program. We've had similar problems at Stennis in our development firings where we test our main engines. I think possibly 3. I believe they told me it was 3. And, you know, they had spring problems, contamination, a few things like that. Of course, that's what we'll be looking for here.
Do we have one more question, Marshall?
For Mr. Hines, do you have any specifics to offer on what experiments will need to be changed out or updated somehow?
Well, we have in some of our biological samples, we have some specimens and some solutions which are sensitive to duration. We have some components which should regularly be checked and run, such as water pumps and tape recorders. And we'll do whatever can be done at the time that is now available. There is no hard limit to most of these things. It is what I said yesterday here, a bit of a question of a Fingerspitzengefühl as to exactly what you'll do. But I think we have the time now to do it right and to get back into a completely normal situation.
Let's move on to NASA headquarters.
This is NASA headquarters in Washington. A.R. Hogan, Ad Astra Magazine, Writers Plus Newsroom. 3 questions. First, could you explain the purpose of the deluge in a situation like this on the pad, and how does the volume and duration of that deluge compare with a normal post-launch deluge? And I have 2 follow-ups, please.
Well, we turn on the aft fuselage deluge in the event that in this shutdown sequence of the engines, one or more of the valves does not close, particularly a main fuel valve, because in that case you'll have free hydrogen around the boat tail, and the probability of fire would be increased. So in the event that would occur, we automatically turn on the water. And we keep that water on until we're assured that all of the engines and all the engine valves are in a post-shutdown safe configuration, which I think, as I indicated, takes about 5 minutes. And those aft sprays, as it were, that's like a firefighting deluge. We don't turn that on unless we do have either a confirmed fire or we have one of these shutdowns. The rest of the water, the pre-launch water, as you know, comes on at launch minus 15 seconds, and that's from the water tank, and that will flow until the tank is drained, whether or not you launch. And of course, that water did continue to flow until some 20 seconds later, and that time the tank was dry, and that part of it was over with.
Is there a follow-on?
Yes, follow-up questions. On the June '84 Discovery launch where you were at T-minus 4 seconds. This is T-minus 3. My recollection is that the only human space launch that rivals an abort this close to launch was one of the Gemini missions in '66. Is that correct? And is an abort more complicated or more dangerous with a shuttle versus the Gemini missions? How do they compare? And my last question is, and the last question from Washington is, there was something mentioned about the closeout crew plus paramedics going to the pad. Is that the normal procedure, the normal complement of people in case there had been a routine decision to call off the launch because of weather? Did the same number of people go out to the pad?
Well, in answer to the last question, it's the same. That's standard procedure. And comparing a Gemini abort to a shuttle abort, well, I was in the blockhouse for Gemini 6, and I would say the atmosphere was just about the same. Didn't take quite as long in Gemini to safe the system, but the results were the same, and the procedures are similar.
I understand we have a question from Goddard.
Yes, this is I.J. Hudson from WRC in Washington. For Commander Nagel, how has this experience affected your confidence in the shuttle, and will you sit in that seat next time a little more at ease?
I feel about the same next time. I had seen the two-pad aborts before. As a matter of fact, when we used to have network representatives from the astronaut office, I was the network representative on the first Discovery flight. And when that scrubbed, and had to explain it on network television, and understood it at that time. So it really doesn't affect how I feel one way or the other. I think it's disappointing that it occurred, but it's heartening to know the system works as well as it does to keep us safe. And I have no bad feelings at all about coming back down here again. The sooner the better, as far as I'm concerned.
Jim?
Jim McKenna, Aviation Week magazine. What was the practical effect of the valve not closing? Where was the gas going that it shouldn't have been at that point?
Goes out through a vent. It vents the atmosphere.
Okay. Would it have inhibited the development of thrust in number 3 at all, or?
Well, it did that by not being at the right pressure. Therefore, you didn't get ignition. See, the preburner has spark igniters in it. It didn't ignite because the pressure was too high. You had helium in there. You didn't have the proper quality to ignite. So, in a sense, and all this happened so fast, and the red line caught us. But again, now these purges are there to help us, make sure we don't have combustible, etc., because they come on after we shut down. Sweep those gases.
Phil?
Phil Chen, Earth News. Personally, I'm surprised nobody asked this yet, but at what point in the count did the SSME-3 controller call the abort? What seconds, how many seconds before T0?
Well, we ought to get you the detailed timeline on that, and we'll do that. We'll pass it on.
And on the two engines which did ignite, did you have a smooth shutdown? Was it fuel rich? Based on all your data, how clean are those engines? And the obvious follow-up to that is, given the fact that the engines have quote-unquote been fired and gone through the equivalent of flight, do you have to swap them out on the pad before you could consider flying the vehicle again?
We may have a problem there. We may want to look at those valves, not just check valves, but the oxidizer preburner valves. And we may have a problem there because we don't like shutdowns during that period. We may have to change those engines. That's being looked at now.
Bill?
Yeah, for Mr. Stover, I suppose. Can you, I realize you don't want to do this, but I'll ask it anyway. I've heard the figure bandied about of $1 million Deutschmarks a week to keep your team in place for this delay. I have no idea if that's even remotely accurate. What is the cost? I mean, how badly do you want to fly next? and how much is it going to cost you to slip this much?
Well, to take your second part first, obviously we want to fly as badly as possibly can, as soon as we possibly can fly safely. That there is cost concerning the mission operations team, the industrial support team. There's cost on the science side, the guys who have to reactivate some of the labs, keep a number of things longer online. I don't want to give you a number here, but you know yourself that the total mission was about 890 million D-marks, and we'll be going substantially above that one.
Sharish over here. That's Andy.
Shurish Date with the Orlando Sentinel for Alex again. When we looked on the videotape, you see this sort of orange-colored flame, what appears to be flame coming out. What exactly is that? Is that improperly burned hydrogen, or?
Are you talking about position 3 or the
Yeah.
other two? The other two, you see the mock diamonds. I saw one of them. I couldn't see the other one. And what you're seeing there, we just didn't have, ignition of the pre-burner. Now, what you're seeing is combustion products from the main chamber and from the other pre-burner being discharged into the main combustion chamber.
Okay, so is that the hydrogen-rich gas that's coming out?
Right. That's right.
Front row over here.
Anatol Johansen. Another check on the check valve. Is it possible that this is just a failure of an individual valve, so you could replace it pretty fast and wouldn't have a long delay? Or is it possible that basically something is wrong with this kind of valve, so you need another kind of valve or reconstruct this, which of course would mean a longer delay?
Well, I think it's the former. We believe we're going to take the valves out and look at it. So we don't believe we could probably change it. We're going to see it, make sure it's not generic, that it could affect if we're going to change engines. We want to be sure we understand the problem. So the first thing is get it out, try to analyze it, do the failure analysis, and explain it. And I believe it'll be that. We're not talking about a redesigned valve. This valve has been there for a long time and had very, very, very few problems, like I mentioned, the 3 that we've had. So it's got a good history.
Gentleman in the blue shirt.
Bill Nelson, Access for Springfield W2X Radio for Steve Nagel. Steve, I was wondering, after the initial flurry of activity in safing, flipping all this switches, going through the checklist, what's the first feeling that came into your mind? A feeling of disappointment that you weren't going, or a feeling of relief that the system did its job? And I have a follow-up.
Oh, I guess probably the first feeling was relief that the system did its job right, and then disappointment. Really, we were busy for quite a while there executing these procedures, Bill, until we got out.
And just to follow up, I just want to confirm, until the shutdown today, was a totally clean count, not any anomaly at all on any system at all?
That's essentially true. We worked a couple of minor problems with the ground support equipment early on when we got into tanking. We delayed tanking some 20 minutes to work on the ground support equipment problem. But the tanking was per the timeline, and as was the rest of the closeout. And really, it was one of those nice, boring launches you hope you have, at least until the last couple of seconds.
Lady in the pink back here.
Amy Hout, SEDS Nova. Commander Nagel, looking forward to this upcoming mission. What do you foresee as being the main benefits coming from STS-55?
Well, I think there'll be a host of scientific results from this mission across the board in terms of life sciences and material sciences, and it's a very ambitious, packed space lab mission with about just almost 90 experiments on it that we're looking forward very much to doing, but it's going to add to our base of knowledge in microgravity about both living organisms and inorganic materials.
This is starting to run long. We'll take 3 more questions.
Right.
Beth?
As well as many other areas, too.
I'm sorry.
No, I just wanted to add that we've got, particularly on this mission, it has a very multidisciplinary character. Also a camera which is looking on the one side to the Milky Way in the ultraviolet, also looking down on the atmosphere to look into the chlorine combinations in a way never done before. And we have an Earth observation camera on there, which is a rather interesting very high resolution camera, which will do test sites all over the world and comparing data with our American friends and others on how to apply this to cartography, photogrammetry, and other strange words like that. So it's a multidisciplinary mission which has, in addition to the microgravity, quite a number of additional points. So just to
That's great.
Beth?
Dickey with Reuters for Professor Stuver. Back to the issue of cost on carrying on your mission support for a while, the number that's being bandied about is 1 million D-marks a week. Is that anywhere near correct?
I don't think it's quite correct, but I don't want to give you a misleading number. That's why I've been avoiding this question on purpose, if you will. I don't want this discussion to go just on a dollars and cents basis. It has a dimension which is much bigger, and the D2 is a step in the logic of our cooperation with our American friends, which goes back 30 years and which I hope goes on for 30 years. That's why we pool all the interests from both sides and make sure this mission goes off well.
Mark Carroll.
Mark Carroll, Houston Chronicle. Could you spot once again where the suspect check valve is on the oxidizer side? I think you said the pre-valve, but if you could just spot that once again. And the failure analysis, I gather that will be done by the manufacturer, and who and where might that be? And just one final question on this process. If these are replaced, is it easier to replace the whole main engine on the launch pad, or do you replace some other assembly, or is that undecided?
Yeah, let me take the first one. It's a valve between, you know, we have pre-burners. These are combustion devices that drive the two pumps, high-pressure pumps. Well, in that system, upstream of that system, these check valves are located there for the purges. So we have two on the oxidizer, two on the fuel, and we believe the one on the oxidizer, that's the pre-burner. Okay, these are check valves. So they're downstream now, the pre-valves, and the pre-valves being part of the orbiter system. This is downstream in the main propulsion system. So they're upstream of the pre-burners, and they're there to make sure that they close when we have ignition and that you don't have backflow, if you will. And so that's the first one. The second one, our contractor is probably Rocketdyne, he's our prime contractor that makes the engine, Canoga Park, Los Angeles. He will probably do the failure analysis, and we're going to have our valve people, our NASA valve people, out there with them when they go through the failure analysis. And I was told just before I came over here, Byron Wood, who's an old valve man, he's vice president for Rocketdyne Engineering. He'll be a good one to head that up. So we plan to follow that. Then your last question depends on the timeline, access, what's involved, and really the CAPE is looking at that. Do you take them out and do you replace them, or do you change engines? And that's all being looked at now by the CAPE. So we'll support whatever it is for them.
And let me add that the major work content associated with this activity is not the removal and replacement of these LRUs. It's the standard inspections and tests that you have to do on any engine that went through a static fire. And that's an invasive process. Bore scopes, torque checks on engine pumps, and that sort of thing. And when you weigh the work content of doing that with the engines on board as opposed to if you had 3 engines ready to go and put in, it comes out to be pretty much equal in terms of the time, but a lot less invasive and a lot less work content if you go with 3 engines, if you have 3 staged and ready to go. So that's what we're looking at.
Irene?
Follows on that a little bit. Do you feel reasonably confident that the work can be done at the launch pad no matter what you decide to do?
Yes, the work can be done. We've done similar work on engines before at the pad, vertical.
Todd, you're the cleanup man.
Tom Boyle, Conservative.
Tom or Tom?
Okay.
Tom Boyle, Tipton Conservative. Mr. Seek, what kind of power levels did the engines get to?
Well, I think the best way to go through the technical aspects of that is we'll get an RTQ that takes us from the failure enunciation by the computers all the way through the shutdown with all the parameters, and we'll supply that to the
Thank you.
Okay. Todd, you're really the cleanup man.
Okay. Todd Halverson of Florida Today again. Do you anticipate there's going to be any additional testing or inspections needed on Discovery? And I'm wondering if Mr. McCool can go over the causes of the 2 previous shutdowns on 41D and 51F.
Well, Bob says he can get you. That's probably the best thing, because I don't recall a lot of those details.
Additional inspections?
Oh, and additional inspection if we change that?
No. Do you anticipate there might be additional inspections or testing needed on Discovery over on 39B as a result of the shutdown?
No, I don't believe so. That's the thing we want to be sure it's not a generic problem. We try to exonerate that they're okay, because they've gone through checkout, leak checks, etc. So we want to be sure, just precaution, but we don't see any additional. Now, it's not to say that we may not come back and say, how about doing bore scope or whatever. We don't see that today.
I'll clean that up. Okay, let me Let me do a few commercials, then we'll let you all go. One will be running replays of the engine startup right after this, running on NASA Select. And those of you with STS-55 badges, those will not be valid after the close of business tomorrow. If anybody needs access, please see one of us in the news center. We do plan to close the news center at the scheduled 6:30 p.m. this evening. If anybody has any problem with that close time, address it to Diana Bowles, Bill Johnson, or myself. And Commander Nagel has an appointment with an airplane at the SLF, and I hope he won't be impeded in making that appointment. Thank you.